Today we're doing 5.4 SSS triangle congruence. Before we get any further, I've been a little disappointed with how many folks have actually been watching the videos, and I am now going to start grading them. So this is the first graded one, surprise. Good job watching the video. So in this corner up here somewhere, it should say something like submit assignment. Once you're done watching the video, go ahead and click on that, and then you'll submit a text assignment. The assignment is to write down what SSS stands for. That's all you got to do, and submit that. So what does SSS stand for? Well, it stands for, you probably guessed it by now, side, side, side. So there's a side, side, side triangle congruence theorem. It's just like our other two. It's kind of the third main one. It says if three sides of one triangle are congruent to three sides of another triangle, then they're congruent. Cool. We can do a couple of examples here. I warn you though, these might be too simple for you. So if you need more complicated things, I'll dig up some proofs for you. So for example, this one here, we have our two triangles. We can say that DE is 20 centimeters, FG is 20 centimeters. So we could say, oh, they're congruent. Then DH and FH, this center point is H, are congruent to each other as well. And finally, EH is congruent to GH. So therefore, those guys are congruent. Then we can say that the two triangles are congruent. Question: is there another triangle congruence theorem we could have used for this? Hopefully you came up with yes. We know that this angle is congruent to this angle because they are vertical angles. So therefore, we also could have used, what is it, DH? We could have used this pair of sides and this pair of sides and angle DHE and its congruence to angle FHG. So just another one to think about. We could have even shown that the two are congruent without this information, but it gave it to us, so we're using side, side, side. Okay. For a couple that might be a little harder, let's go ahead and try this. So go ahead and try 5 and 6. Pause right here. Pause. Okay, 5. You may think, oh, quick glance. 54 is congruent to 54. 38 is congruent to 38. But this 28 is not congruent to 32. But remember, to prove that they're not congruent, we need to find one side that isn't congruent to its corresponding side. And we're not sure what sides correspond to which sides. It doesn't say that anywhere. It doesn't list off points or anything. So we need to show that, say, a side RQ here is not equal to any of the sides over here. The book's a little lazy about it, and it kind of just assumes what sides correspond with which other sides. But we can be a little more thorough and say that side RQ does not equal any of the sides over there on the left. What about 6? 6 is weird, there's no numbers. So how are you supposed to say that they're congruent? Well, it's pretty doable. We have these little tick marks here. These tick marks indicate congruence. So KJ is congruent to LJ. KG is congruent to LG. And then we need one more side, and that's that shared side, right? So we can use the reflexive property to show that that's congruent. Yep. So therefore, these two triangles are congruent. All right, we can also use, we need to start thinking about just general triangle congruence, and just using side, side, side as one of our 3 ways to prove that. So we can do a few more examples. They like to do some algebra in here too, just to keep you guys on your toes. So this one here, blah, 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 here's the setup. We got this side is 4 inches, this side is 4 inches, this side is some weird number. This side's 4, this side's 4, this side's 4. It's an equilateral triangle. So since it's equilateral, it's kind of nice because we don't really care which sides correspond, so they all should be the same. So we need to make NO equal to 4. In this case, they came up with PR as the corresponding side. Okay. So we need to make the two congruent. So to do that, we need x times 3 to minus 11 to equal 4. therefore equals 4, right? We can add 11 on both sides, gives us 15, divided by 3 should give us 5. So x equals 5. Cool. See if you can do number 7. So go ahead and pause here. Okay, this guy, same sort of deal here. For what value of x and y can you use a triangle congruence theorem to show that the triangles are congruent? So this one, again, it doesn't say which triangle congruence theorem. And in fact, we won't use side, side, side. We'll only use, let's see, we know this angle here is 90. So cool, we can use that angle. We have this angle. We have this side, right? And we have this side, or we can at least set it equal to something. So we have that side and that side. And we don't have any other sides, so that means we have to use another angle. So we can use angle, side, angle, right? That means we need to figure out what angle h is. 180 minus 90 minus 60 is 30, so this angle is 30 degrees. And then finally we can set this side here, 8x minus 12 equal to 12. 8x minus 12 equals 12, that means 8x is 24, x is 3. So we get x equals 3. The y part here is a little extraneous. We just know that 7y plus 4 is equal to 60. So that means 56 divided by 7 gives us 8. So we have a value of y right there. Okay, see if you can do number 8. Pause. I kind of like this one. So it says that there's isosceles triangles, right? So isosceles triangles have matching side lengths for 2 of the sides. So it says one side length is 8 centimeters. So let's say that one's 8. The other side length is 12 and 12. But there's also one other type of triangle we could make here. It could be one more like this, where this guy is 12, and this one's 8, and this one's 8. So just something to think about. We could make, again, just knowing one side length is 8, one side length is 12 isn't enough. We need an angle in there somewhere, or a third side to show that it's congruent. We don't know what that third side is. We don't know if that third side is 12 or if the third side is 8. It's not enough to just say, oh, it matches one of the other sides. So just keep that in mind. Okay, that's it. Don't forget, go ahead and do the submission thing and write down what SSS stands for in order to get full credit. If you're watching this video with someone else, make sure you log into your Canvas account so I can give you points for it. Otherwise, you're getting a 0. Cool. Have a good one. Thanks. Bye.